Hello everybody, this is your teacher again, Miss Irene, and this is the session 2 for consumer chemistry. Okay, for this week, we're going to talk about the skill check, the hydrocarbons, alkanes, alkenes, alkynes, and the activities. Okay, we're going to do this in class, so you may pause this video and the answers will be sent to you also. Okay, after that, let's go to the review. Last week, the main topic was about organic chemistry. This is a study of compounds that contain carbon. It is one of those major branches of chemistry which talks about almost all of those products, consumer products that we buy and use every day. In organic compounds, they are usually represented as this structural formulas, this stick figures here, and also in ball and stick models. Okay. Also, last week, we learned about the concepts of organic and inorganic compounds. When we talk about organic compounds, their bonding is almost entirely covalent. So among their bonds, the electrons are being shared. In inorganic compounds, their bonds are ionic. It means that there is a transfer of electrons. Look at this. The electron is now on the chloride. Alright, so you may review about these concepts also in the previous video that we had. Okay, let's have a review. Identify if these examples are organic or inorganic. You may pause this video also. This one is calcium chloride. Is it organic or inorganic? It's inorganic. How about this one? C25H52. Organic or inorganic? Of course, organic. How about this? This is organic. This one, carbon monoxide, it's inorganic. And carbon dioxide, also inorganic. And this glucose here, this is organic. Okay, so remember that the exceptions are those carbonates, the oxides. We also have sulfides, so you can read the previous handouts about the exceptions. Okay, so again, this is Mr. Friedrich Wöhler. He was the person who proved that we can synthesize organic compounds in the lab. So he made this without the involvement of a life process, and this is why people adapted a new definition for organic chemistry. He is the father of organic chemistry. He mixed this ammonium chloride and silver cyanate, and surprisingly, he was able to synthesize a white substance called urea, which was previously created before from urines of people. Yes. Okay. This is the carbon atom. A carbon atom is the star of organic chemistry. This one is a 6-proton atom, and it has also 6 electrons and some 6 neutrons also. In its neutral state, it's like this. This is an example of a planetary model. The electrons are shown like planets around the nucleus. And in this one, there are 4 electrons on the outermost orbit. That means it has 4 valence electrons. The 4 valence electrons enable carbon to share 4 electrons to other atoms. So the properties of carbon, it can bond up to 4, and it can make 3 types of bonds. The 3 types of bonds, it's a single bond, a double bond, and of course, and of course a triple bond. So it can make 4 bonds, but 3 types of bonds. Okay. And these are again the representations. We can have a molecular formula, structural, ball and stick model, space filling model. In the previous video where I taught about the writing of structural formulas, I mentioned about empirical formula. Well, I really made a mistake right there, so it was actually molecular formula. Molecular formula tells us about the actual numbers of atoms of a specific element in a given compound or molecule. So, for example, hydrogen, the molecular formula of this H-H is H2. Water, H2O, it's like this. So it really shows how many hydrogen atoms, how many oxygen, and this one too, N, only one. H3, that means there are 3. And there goes methane. So you have C, just 1. When it's 1, no need to write the 1, just like in exponents. No need to write the 1. Okay, and H, there are 4. Okay, again, I stand corrected. That was molecular formula. Empirical formula is another version. We're going to learn that in another class. Okay, structural formula tells us how it looks like in the arrangement of the molecule in a 2D version. Ball and stick model and space filling models are 3D representations, and they can have these ball and stick figures. In a space filling model, the bond cylinder was taken out. This is a closer representation to what it actually looks like in actual life, because they tend to overlap when it comes to sharing of electrons. They share their electrons, right? Okay, so it's not really that far away. So this is a little closer to what it really looks like. But for the class, we're mostly going to use the structural formula and molecular formula. Again, 4 types of formulas. Molecular, this one. It tells you how many atoms for a particular element in the given compound. But it's not that useful or very useful for organic compounds, because as they tend to branch out, there are instances where you can have the same molecular formula but different structure. I mentioned about that in the previous video on the writing of structural formulas. We are also going to learn about that in future lessons. Okay, structural formula, this one. Now, condensed structural formulas. In a condensed structural formulas, it also shows you the sequence of the units of the molecule. So for example, if we have this, it just writes the sequence. For example, CH3 is this, and CH2, and there's a 3 here, and a CH3 is for this. Why do we write it like this? So in actuality, it looks like this at first. So CH3, CH2, CH2, right? And this one also, CH2, and lastly CH3. But this is also correct. This is also a condensed formula, but we can make it more condensed, just like this, by having this in a shorter way. And to write this, we just write the repeating unit for this one, nagbalik-balik ang CH2. So you write CH2, and then you put parenthesis, and then you write a subscript that tells you how many times siya nibalik. So CH2 katulo, so you write 3. CH2, then parenthesis 3. So this is a more condensed version. Another example, we can have CH3, CH2, CH2, CH2. It can be a long chain, and then another CH2 and CH3. So to write that, you can just first write this CH3 because it's not repeating for this time. But look, it repeats for CH2, CH2 again, CH2. You just count how many they are. So you just write CH2 parenthesis and then count how many they are. 1, 2, 3, 4, 5. So it repeats 5 times. And then you copy CH3. This is a condensed formula. This is a more condensed formula. Both are correct. Okay. Then let's proceed. Line diagrams. The end of line segment represents a carbon. It is assumed to satisfy each carbon octet. This one, it is a more simplified version. Why? This time we're not writing the C, nor we are writing the H. So it's not shown. What it actually is that there is a C here, a carbon here, a carbon here, a carbon here, and a carbon here. So we are removing also the H. So it is assumed that naa na H would around sa C. Okay, at the ends, it's always 3. So the pattern by the end, tulo ang nasa C. In the middle, it's duha-duha. And sa tumoy, tulo-tulo. Okay, so every time you write a single dash, it means you have a carbon here and a carbon also in the other end. That means duha na naka-carbon. Next, if I write like this, so that means pila naka-carbon? 1, 2, 3. It's 3 carbons. How about this? 1. Usually we start by going up. And this one. So, don't forget that there are carbons at the end. So, 1, 2, 3, 4. If I want to have other elements, you just write the elements itself. For example, the oxygen. So, you can write this. So unless it's indicated, it's not carbon this time, it's oxygen. So at this end, there's no carbon. It's oxygen and a hydrogen. So you can have a dot here. And no, you can have a carbon here. Carbon. How many carbons? 1, 2, 3. Only 3. But there's one oxygen and 1 hydrogen. Okay, let's have a structural formula. Okay, I have 1, 2, 3, and 4. 5 carbons. And then let me fill that up with the hydrogens. Okay, so yeah, this is really taking a while. Yeah, you have hydrogens here. You must remember that there must be 4 bonds around a carbon. It can be triple, double, or single. Just count them to be 4. If mo 5, it's wrong. Now let's write the condensed formula. How do we write the condensed formula again? Condensed tells you the sequence. So it's CH3, CH2. Here it's CH2 again, and another CH2 and a CH3. And then we made a more condensed version of this one by writing CH3 parenthesis CH2, and it repeats how many times? 1, 2, 3. 3 times, and CH3. That is a more condensed version. Now, how about the bond line or line diagram? So you write your C. Every time you start, there is now a C. So if you write this, 1 carbon is here already at the end and another. So it's 2. So how many should we have? 1, 2, 3, 4. Let's write a molecular formula first. CH. So how many carbons? 1, 2, 3, 4, 5. And how many hydrogens? That'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There should be 12. So you should have 6 carbons here. So we started with this line, 2, 3, 4, 5, 6. So this is your bond line diagram for this kind of chain or this kind of compound. So Make sure or always remember that there are carbons at the end unless it's indicated that it's not, just like this. Okay, so 1, 2, 3, 4, 5, 6. Okay. And then how about we go next to the page about hydrocarbons. So let's now go to the topic about hydrocarbons. When we talk about hydrocarbons, before we dive in, let's have our objectives. In this topic, we're going to distinguish between saturated and unsaturated hydrocarbons. Next, describe alkanes, alkenes, and alkynes. Number 3, identify hydrocarbons and draw models used to represent them. Okay, let's go. For this one, there is the system created by a group of scientists, an international group of scientists, and they aid in the communication between the chemists by setting rules and standards in areas such as chemical nomenclature, naming, and all those things, terminologies, and standardized methods. And this organization is called the IUPAC, which stands for International Union of Pure and Applied Chemistry. Pure and Applied Chemistry. So there is also another version for this one in physics. So it's International Union of Pure and Applied Physics as well. Okay, they give us the standards and we follow them. The chemists follow them, and when we follow these kinds of rules, we eliminate some risks of miscommunication among our research results or in the things that we talk about when it comes to chemistry. Okay, hydrocarbons. These are the simplest organic compounds, and we call them hydrocarbons. They consist of only the elements carbon and hydrogen. Okay, there are thousands of hydrocarbons, and they're everywhere around us. And again, these are our models. We can have the molecular formula of methane, CH4, a structural formula, a ball and stick model, and a space-filling model. Okay. Carbon atoms bond to each other by single, double, or triple bonds. And when they contain only single bonds, we call them saturated hydrocarbons. Because when we say it's saturated, it's filled, right? Just like in your topics in your basic chemistry, saturated, it's full, right? So, for example, your carbon has 4 valence electrons. That means it has the ability to accept 4 bonds. So, saturated means this ability is being used fully. So, it has held 4, a maximum of 4. But when it contains at least 1 double or triple bond, it's not unsaturated at all. So it is called now, unsaturated hydrocarbons. So for example, you have a double bond carbon or a triple bond carbon. So if these contain a double bond or a triple bond, it's now called unsaturated. Saturated if only single bonds na maximize ang all niya nga makahold og 4. This one holds 4, but it tends to be like mura na siya usa kay carbon to carbon or another element man. So mao ni siya nga saturated gani full iyang capacity. Just like murag sa saksakan sa plug ba, outlet. So napuno tanan, mo na siya saturated tanan nga outlet. Okay. What is a hydrocarbon that contains only single bonds called? What is it? It's saturated. Basta only single bonds, saturated. Okay. Hydrocarbon consists of families of alkanes, alkynes, alkanes, alkenes, alkynes, and arenes. So we're going to talk about arenes in another chapter. When we say alkanes, it has only single bonds. Alkenes, more bonds like double bonds. One or more carbon-carbon triple bond is for alkynes, and for arenes, this now encompasses those hydrocarbons that have rings, such as this kind of structure called benzene. Okay, so we're going to learn about these in the next few slides, so just hold on. Okay, overview lang ni, overview. Okay, for now, let's focus on these three. Okay, when we name organic compounds, they have this, what we call aliphatic hydrocarbons. When we say aliphatic hydrocarbons, they contain only hydrogen and carbon atoms. So it is a more specific, because there are hydrocarbons na naanay mga oxygen. Oh, no. That's not what I meant. So there are organic compounds that naanay mga oxygen and mga nitrogen. So they are different kinds of classification na. So for this one, focus ta sa hydrocarbons or aliphatic. And when they're aliphatic, that means they are straight line chains of carbon. Alicyclic hydrocarbons, on the other hand, na-form siya og mga ring. Just like atong makita ninyo nga symbol kasagaran, mo siya circle, inana, or mo siya pentagon. Or you can have a triangle or a square. It's possible. Okay, so na mga inana nga ring. We can have a hexagon. Hexagon. This is a hexagon, but it's not working right. Oh no. Never mind. Okay, alicyclic ba sa circle ha, then aliphatic mga straight chained or branched. Let's go. In this part, naghihapon ang formulas. We will study about these formulas later in the next few slides. So remember, your alkanes are saturated hydrocarbons, alkenes unsaturated, alkynes unsaturated. Okay. Now, when we name organic compounds, we really have to name them because they tend to go on long chains and it's hard to recognize them. So the scientists that organize these rules have set up these things to remember. Okay. For organic chemistry, the names have a root and a suffix. In your module, the root also refers to prefix. So remember, in your English class, you have affixes, and then these could be prefix, or this could be suffix. A prefix is like something that you add before the word, and suffix after the root word. Okay, the root describes the number of carbon present in the chain or ring. These ones are the ones in red. So these are things to remember, such as meth, eth, prop, but, pent, hex, hept, oct, non, dec. So this corresponds to a number. For meth, it means there's 1 carbon. Eth, 2. Prop, there's 3. But, there's 4. Pentane, there's 5, and so on. Hex, 6. It's familiar. Hept, not so much familiar. It's 7. Oct, familiarly 8. Non, 9. Dec, it's 10. And the last, the ones that are in black, are the suffix. It describes the type of compound that you're dealing with. So it tells you the type of carbon bond present. So we have suffixes for alkanes, alkenes, and alkynes. So this one, ane is for the alkane family. We're going to learn about that in the next slide. Okay, so just a quick tip. It'll be better if we understand and memorize these prefixes indicating the 1 to 10 carbons. So simple life, kutob lang sa tasa 10. Okay, this could go longer, but kutob lang sa tasa 10 for now. Okay, so these are the suffixes. For a single bond, see carbon to carbon, or what is this again? It's an alkane. So for an alkane, the suffix, it ends with this dash -ane. The double bond, C to C, it's, what is this again? Alkene. Okay, it ends with -ine. And alkyne triple bond, it ends with -ine. Okay, for example, 3 carbon atoms, all single bonds, prop plus ane, so propane. 5 carbon atoms, double bond exists, and it's pentene. So 8 carbon atoms with a triple bond, it's octane. So for this one, this is a simple version because sometimes there could be many double bonds and there could be many triple bonds, but let's just keep things simple. Next week, we're going to talk about those branch things and we're going to name them. Okay, how about I have 7 carbons, and then there is a double bond. So how am I gonna name it? So assuming I'm giving you only one double bond for simplicity. So 7 carbon, the 7 is hept. And one double bond, it's -ene. So heptene. Okay. How about 7 carbons? 1 triple bond. It's heptine. Just like that. If a compound has a double bond and a triple bond, it will end with -ine because the triple bond is a superior bond. So every time gani magkuyog ang double bond ng triple bond, ang imo dayong compound is considered na dayon nga alkyne. Okay. Okay, let's learn about these 3 words a little closer now. So alkanes, alkenes, and alkynes. Alkanes, so it's A in the middle. Alkanes are considered as aliphatic hydrocarbons due to the resemblance of the physical properties of the higher members of this class to those of the long carbon chain molecules found in animal fats and plant oils. This is from the Greek word aliphar, which means fat or oil. Okay, so main idea is that alkanes are hydrocarbons that contain only single bonds. So this is an example of a simple alkane, methane. There is only 1 carbon and all of the bonds around it are single bonds. This is ethane or ethane. So you can have 2 carbons and only single bonds are there among them. Okay. So here are some examples of straight chain alkanes. Straight lang sa takaron. Ang branched guy next week pa. Okay, structural formula. It's like this. And the ballistic and the space filling model. And so on with propane and butane. When we say propane, prop stands for 3. But stands for 4. Okay. Here is also a line angle formula and a ballistic model and a condensed structural formula for these 3. Okay, so again, propane, we have CH3. It is assumed that there is a carbon here, a carbon here, and a carbon here. So it's just this little angle. When we go to butane, we added 1 more, right? So it's CH3, CH2, CH3, but this time there is 1 more unit. Okay, so what it looks like is, okay, for butane, it is that we want to add 1 more from the propane. So if your propane looks like this, see, my drawing is really crooked. Okay, we want if you want to add more, this carbon would replace this one. So it is a type of reaction that we're also going to study. Okay, so here it replaces the hydrogen at the end, and it becomes 4 now. And the same process goes for pentane if another carbon is added. So again, it's an alkane and only single bonds exist. Okay, let's try to answer. You can pause this video to see for yourself, and then I will give you an answer. Okay, how about pause now? Okay, let me show you the answers. For methane, the general formula is, what is it? The molecular formula, C, meth stands for 1, ane, single bonds. So it's CH4. Let's go first with the structural formula, C. So it's H. Okay, so condensed formula, we have nothing to condense, so it's just CH4. For the bond line formula, how am I going to do that? So for this one, for the bond line formula, since it's only one carbon, so we can't write a line. We can't write a line, so just write the CH4 itself. I mean, it's not applicable. Okay, how about for the hexane? Hex means 6 and single bond again. So, C. Okay, so that means we have 1, 2, 3, 4, 5, 6. There are hydrogens. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, and the condensed formula for that, you have CH3, and then CH2, 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 CH2. So there are 4, and another CH3. But if you write the longer version, it's okay too. Bond line formula now, we must make 6. So 1, 3, 4, 5, and 6. Okay, so if you notice at the patterns, we can get the general formula for alkanes. It's this. So properly it is written as CnH2n plus 2. That means if you have the general formula of CnH2n plus 2 for alkanes, so we can easily predict it. For example, if it tells you you have 6, and then what you do is just multiply 6. 6 is your n. So multiply 6 by 2 times 2, and then add this with 2 plus 2. 6 times 2, it's 12 plus 2, this is 14. So it's 14. How about C8? H, how many? So this is your n. So n, 8 times 2, this is 16, plus 2, this is 18. So C8H18. How about if I do the reverse? CH22. How many would that be? How many carbons? So what we do is just we subtract the 2 first. So 2 minus 2 is 20. And 20 divided by 2, it's 10. So that means it's 10. If we go back, C10H, diba? Ang imong n kay 10 man. So 10 times 2, 20. Plusan og 2, it's 22. So okay, so this is how you write the molecular formula for alkanes. And this is the general formula, CnH2n plus 2. Try some examples for yourselves. C15H, it's 32. C16H, 34. C blank H, about 26. It's so 26 minus 2, it's 24. 24 divided by 2, it's 12. Okay. Next. So these are some of the condensed formulas of the first 10 alkanes with unbranched chains. Unbranched, just a straight line. A few things for you to memorize, but it's okay. You can do it. Okay, these ones also are some of the structural formulas. So the general formula is this: the condensed, more condensed, and then the expanded or the structural formulas. We've learned about this, so there is no need to memorize actually. It is just a skill to learn on how to draw these. Okay, observe this table. Look at the boiling points from methane going down to the decane. Is it increasing? Is it decreasing? It's actually increasing. Why could it be? What's the reason? Well, the reason is, look at first the number of atoms, the number of elements. So in CH4, and then it goes from here to here and to here, it becomes a lot more. So when it comes to boiling, the boiling point is the point in which the liquid molecules, they start to become gas at a constant temperature, and this is your boiling point. So as they become gas, for them to become gas, they need energy for the bonds to be broken so that they can move freely and become spacious like a gas arrangement. So they need more energy. They need to have more added heat. So the temperatures must be higher for this to boil. So as it becomes more atoms, it becomes heavier also. It becomes a greater molecular weight. Molecular weight, there is an assigned mass for each element. You can see it in your periodic table. Your carbon is 12.0 grams per mole, and your hydrogen is 1.01. But no need to memorize this one. This is just for some examples. So if you add this one, carbon, and then multiplied by 4, this is the mass for each one. And then as it becomes more and more, the molecular weight increases. As your molecular weight increases, your boiling point also increases, because there are more bonds to break and needs more energy to do that. So we get the energy in the form of heat. So there must be a higher boiling point. Okay. Properties of alkanes. Physical properties of alkanes. Compared to water, methane boils lower and melts. Methane boils and melts at lower temperatures than water, just like this. And the methane molecules have little intermolecular attraction compared to water. So methane molecules are nonpolar and do not form a hydrogen bond. So just this terminology, polar, nonpolar, it talks about how at some point of the atom, just like a magnet, diba? In a magnet natay North Pole and South Pole. So you can also have that in a molecule. So for example, if you have a methane atom, so this is behind and this is in front. So this is the tetrahedral shape, right? Tetrahedral. They tend to form like a triangle also below. There's no positive side or negative side. Here, it's all balanced. So there are also types of atoms, just like water, nga na ay positive side and negative side. You will just learn that in advanced chemistry classes. So just remember, in this one, there's no positive pole or any negative pole. So it is just equal and balanced. So this is alkanes are non-polar. You can also look at videos talking about this. Okay. When it comes to chemical properties inside, so the alkanes have low reactivity because they are nonpolar and have no charge, and because they have strong single bonds between carbon atoms. So alkanes are strong bonds also, and they're nonpolar. They have low reactivity because they only have this one electron and one electron here on this side. Not so much electron density. We'll just compare it to the next examples of alkenes and alkynes, and you'll see. Okay, let's now go to alkenes. For alkenes, the main idea is that alkenes are hydrocarbons that contain at least one double bond. So if it now has a double bond, at least one, it's now an alkene. Okay, so these are some examples of alkenes. Can we have an alkene with only one carbon? What do you think? Can we make a double bond with carbon? And then how about, we can't have it with an H here. So, because H can only hold one, so it always starts with ethene, C2. So, in an ethene, it's like this, C and another C, double bond, and this. So, there's an H. Okay, so these are some of the examples. You can see that there are the double bonds here. You can also have it in different places around the chain, and there will be a different naming rule for that. Okay, here also, condensed structural formula. Okay, this is the general formula for alkenes. For example, for alkenes, we have, again, alkene, okay, C, double bond, H here. So if you count, you have 2 carbons and 2, 3, and 4. So the general formula is CnH2n only. Okay, so for example, if we have C4, then we can expect, so 4 is your N, so 4 times 2 is equal to 4. So, it's 8. So C4H8. How about C5? So expectedly it's times 2, just 10. How about C7? It's H14. How about C blank H22? It's just divided by 2, so it's actually 11. C blank H30, so it's 15. So when it seems like it's just multiplied by 2, this is an alkene. Okay, next. So this is another exercise for you to try. You can pause the video and then see the answers. Let me write the answers. C2H N. So your S stands for 2 in double bond. So condensed formula, CH2 double bond CH2. Structural formula, it looks like this. Bond line formula, not so far from each other. Hexene, hex stands for 6 in double bond again. So C6. And then the formula, 2 times N. So your N is 6, so N times 2, it's 12. So we must write the structural formula first to make it easier. So C, 6 of them. 1, 2, 3, 4, 5, 6, and then I place my double bond here at the beginning. And then complete with the hydrogen that it needs. Okay, H. Okay, so to write the condensed formula, it tells us about the sequence. So CH2, then you have a double bond and a CH. Then next to that, we have a repeating unit of CH2, CH2, CH2 by 3 times. So we can have a parenthesis of CH2 3 times, and then at the end there's a CH3. I hope I'm not mistaken with this. If there are any corrections, just write them at the comment section. Okay, for the bond line formula, we start with the first C, and the first line indicates 2 already. So 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You can do it better with the better lines. Okay, next. So here are the other structures for alkenes. For alkenes are also nonpolar and have low solubility in water, and this time they are more reactive than alkanes because the double bond increases electron density between the 2 carbon atoms, providing a good site for chemical reactivity. So in between the double bond, there's an electron here and electron here. So there are more electrons here. So electrons magyud ang magdalagbida aning mga chemical reactions. So if there is a greater electron density, they can easily react whenever another atom would try to replace it or make a reaction. Yeah. So alkanes now. Alkynes are hydrocarbons that contain at least 1 triple bond. Okay. So unsaturated hydrocarbons that contain 1 or more triple bonds between carbon-carbon atoms are called alkynes. It ends with a suffix -ine. Okay, so these are example models for acetylene, or the simplest alkyne, ethine or acetylene. Sometimes it's ethene or ethine. Okay, so this is a ball and stick figure, a space filling figure, and a structural formula. So it looks linear actually in the geometry. More like linear. Okay. Alkynes. These are examples of alkynes. We also cannot have a single carbon alkyne. So it really starts with 2 to show the triple bond, because only another carbon can hold another 3. We can have another element, but since C and H only ang mga hydrocarbons, so it needs another carbon. So these are examples: ethine, propine, ethene, but it's ine, so propine, butane, 2-butane. You can see that there's a numbering here, both butane, but you will learn it later. This is also an old version of naming, so there's a different way of naming this. So next to exam. Straight chain and branch chain alkynes are named in the same way as alkenes, except in the ending is -ine. Okay. The simplest one is the acetylene, or the ethine, or the ethene. They have physical and chemical properties that are similar to alkenes also, but they are generally more reactive because in triple bonds there are more electrons. So these triple bonds cause even larger electron densities than double bonds, so more reactive. Again, these are some examples of structural formulas, condensed formulas, general formulas. Okay. Okay, as we go on up to the 10th one, it's the D sign. Okay, no need to memorize, but just learn the skill of writing. Okay, so the general formula, by the way, for alkynes, what is it? Okay, let's have an example. So we're now at the alkynes. Okay, for the alkynes, for example, you have the simplest one, 1, 2, 3. So let's count. C2H, how many? 2. How about for 3? 1, 2, 3. 1, 2, 3, 1. H. Okay, so it's C3H. 1, 2, 3, 4. What is the pattern? How about 1, 2, 3, 4? Okay, so there are how many carbons? C4H, 1, and H is 1, 2, 3, 4, 5, 6. The pattern is C, your N here, you multiply by 2, but subtract it by 2. So 2 times 2, it's 4 minus 2, 2. 3 times 3, 6 minus 2, it's 4. 3 times 2, 6 minus 2, 4. 4 times 2, 8 minus 2, it's 6. How about C8? So H, this is your N. So 8 times 2, 16 minus 2, it's 14. So H14. How about C10? H, what is it? 18. Okay, because it's 10 times 2, 20 minus 2, it's 18. How about C blank? H 22. Minus 2. What you're going to do is you subtract it by 2, so 20 divided by 2 it's 10. No. You add by 2 first, so it's 24. Supposedly 24. 24 divided by 2 is 12. So 12 times 2, 24 minus 2, 22. Okay, this is for the alkenes. The general formula is CnH2n minus 2. Okay. Summary now. The first hydrocarbon that has single bonds is called alkene. Single. General formula is Cn. How should we write it again? Alkenes. Single. CnH2n plus 2. For alkenes, double bonds. CnH2n only. And for alkynes, finally, triple bonds. And CnH2n minus 2. So plus 2, nothing, and then minus 2. So that's the summary for the 3 types of hydrocarbon families under aliphatic hydrocarbons. So see you all for the activities that I will be sending at the Google Classroom. And thank you all for watching up to this part, and see you all for next week's lesson, which is about the naming of these kinds of compounds. Okay, goodbye everyone.